All right, let's get this thing started. First off, welcome everybody. My name is Neil DeMajor. I'm the Vice President of Sales and Marketing here at Imagine. You are joining us for the Imagine Academy Quarantine Sessions number 14. This is actually the grand finale, the final quarantine sessions that we're doing. We've been doing these for the past, 2 months now since this thing's been going on. And we've had a great response from the audience. We really appreciate everybody joining us for these, and we really hope that we put out some great content that'll really help everybody up their digital game and come out of this quarantine smarter and more efficient than they were before. So for today's session, we're doing something really cool. We're going to be focused on a full arch all-on 5 restoration. But what's unique about this case is that our panelist who's going to be presenting has done this 100% digitally. And part of what has allowed him to do that is the use of a product from our company, the impression scan body under the MIST brand name. Now, all these products can be found on our website, imagineusa.com. And the impression scan bodies are a really slick technology that we're going to be talking about here very shortly. So stay tuned for that. This is going to be a little on the long side. This is a 2-hour webinar. We've got a lot of great ground to cover. So let's get right into it. Let me announce our presenters here today. First off, I'm going to have my friend and colleague, Imagine Chief Technology Officer Josh Townsend. He's going to be introducing us to the MIST impression scan body, a technology that we've patented here at Imagine and Josh helped develop. So he's going to start off by introducing that to us, letting us know what it's all about, what the benefits are, and how you might be able to leverage that technology to be more efficient in your lab. With that done, Josh is going to hand things off to our good friend, customer, and overall ExoCAD power user, Joe Santos, who you might know as the operator of a great little boutique lab called Virtual Access 109 out of the Phoenix area. And Joe is going to walk us through this all-on 5 case, which is a real case that he did a couple of weeks ago, using the impression scan bodies and using ExoCAD to design the full arch case. So before we get right into it, I just want to let you know that first off, we will be recording and posting this webinar on our YouTube channel. So if you want to watch it after the fact, or you know somebody who you think might benefit from this information, send them to our YouTube channel. It's just hop on YouTube and search for Imagine USA, and you'll find this quarantine session as well as the other 13 quarantine sessions we've been doing for the past several weeks here. So check that out if you want to get more information or just watch it again after the fact. Also, we really want these webinars to be interactive, dynamic type events. So if you have questions or comments or things just aren't clear, if we go over something too quickly and you just need clarification, send us a quick chat using the chat function here on Zoom, or you can send a question through the Q&A box down at the bottom. Both of those can be found at the bottom of your screen. I'll be keeping an eye on those throughout the course of the presentation today. And if anybody poses a question, I'll be sure to get that to our presenters and we'll get it answered for you straight away. So without any further ado, I'd like to introduce Josh Townsend, Imagine CTO. And Josh, if you can go ahead and share your screen and let us hear you, we'll be able to get going with the webinar today.
All right, perfect. Hey, thank you for the great introduction, Neil. Thank you to everyone as well, too, for joining us today. So to start off, I guess there's a question in your minds, possibly. What is an impression scan body? So basically, it's exactly as it sounds. Just as if you are scanning from a scan body from your normal stone models, you now have the capability of utilizing our scan bodies to scan directly from your implant impressions. So basically with this, it is a scan body used to capture the overall implant possession directly from your impression coping itself. All right, so now do keep in mind that Imagine is currently a patent holder for this product in the US. So if you have been looking for a solution like this to incorporate into your digital workflow, you are in the right place and working with the right company.
And just to pose a quick question there, Josh, I mean, so a patented technology means this is a pretty unique bit of technology. This isn't something that people have seen all over the place or might be really used to. So this is definitely, in order to get a patent, it has to be something really, unique.
Yeah, it has to be a unique device, definitely. Yeah. It's been a long process, but we definitely got into place. All right. Well, I mean, let's start diving in. So basically, what I want to cover now is basically the benefits of the impression scan body itself. Now, do keep in mind that I will be covering a majority of the introductory information regarding the product, whereas our main man, Joe Santos, he's going to be covering further details here shortly on how to best utilize these scan bodies on a full arch design. And so basically, he's prepared that for us today, and he's going to go over some further details as to why this component has been beneficial to his laboratory as well, too. So first off, the impression scan body, it works both with closed and open tray impressions. You may have noticed from the picture that I was shown prior that there is no screw access hole on the top of the scan body. So basically, the reason is because just like an implant analog, you're going to be using the supplied impression coping screw to screw the scan body down to the impression coping. Now, I do highly recommend, if possible, to work off of an open tray impression. And the reason for this is that when working from a closed tray impression, there's always the chance of tearing the impression or improperly seating the impression coping down when removing and installing the part back into place. And as with many other workflows, understanding and limiting the amount of possible errors introduced is key to a successful workflow. So, much like your current product offerings are ready for modelless implant crowns, and this can be based off your doctor's intraoral scans, you will now be able to offer a modelless implant crown based off of your received impression. So, as you may already know, there are still many doctors out there in the market that are not currently utilizing an intraoral scanner. So, this component basically helps to fill that void in order for you to add another avenue to your digital workflow and to avoid pouring up a stone model for your single implant restorations. So, many of you might be scanning your impressions already and for your crown and bridge cases. And much like processing for these cases, you will want to make sure that you have your settings dialed in, especially when it comes down to your occlusal and proximal cuts for a successful modelless implant crown.
Hey, Josh, quick question here from our audience, actually from our friend Ben Mueller up in Nova Scotia there.
Yeah.
Are these Health Canada approved? And if not, do we have any plans to get that in place?
Well, since it's a scan body, it's not going to be used intraorally as well, too. It actually does not need FDA approval, or I believe not for the Health Canada approval as well, too.
Hmm.
Um, I can look into this a little bit further, but I might not have the right answer for you. But so far, right off the bat, because it does not need FDA approval, shouldn't need Health Canada approval.
It's a good point. We'll look more into that and we'll get back to you there, Ben. Another question from our friend Dr. Nathan Graves here in the
Yeah.
US. And a good question, why not just scan with an intraoral scan body? Which is a good point, but I think intraoral scan bodies aren't suitable, or well, intraoral scanners aren't suitable for full arch cases, right? So maybe Dr. Graves has a good point for single unit cases, but for full arch, you really can't use an intraoral scanner for a full arch case, right?
Yeah, well, I mean, one part is that, for laboratories at least, some doctors, they don't have an intraoral scanner and may not even have the plans in place to utilize an intraoral scanner, right? So this kind of covers grounds for at least the lab aspect so that they'd still be able to provide a digital workflow for these types of cases. Again, if the doctor does not have an intraoral scanner. Now, even though you may have an intraoral scanner, Joe actually has a great point that he's gonna probably bring up during his presentation. But he kind of goes over immediate load cases, and basically for these cases, there might be quite a bit of blood. It might be hard to utilize an intraoral scanner at that point. And what may be easier at that point is to take an impression, be able to complete the case.
It's a great point.
And I'm pretty sure that Joe's going to be very excited to actually portray this information out there. So I'll leave it at that. All right. So if you look at this picture here, you'll notice a couple things. First, a perfect scan of your tissue, which is going to help you quite a bit with further designing your emergence profile. And second, a capture of information all the way down to the interface. Now, this is not crucial to actually acquire, but I actually do love having this information available when it comes to the interface. And this is mainly because it provides me a good double check method that once my design is complete, I selected the correct library files and even the implant size. All right, so basically with this photo here, you're gonna notice a lot of emotions tied in with this picture here. So basically, it shows a picture of me working on a case where everything was going, pretty smoothly up until I tried screwing the scan body down into the analog itself. And at this point, you will notice that my scan body will not seat due to the tight space with the adjacent teeth. Now, generally, when you come across a situation like this, after scanning the cast for the contacts, you may need to chop the contacts down to be able to insert the scan body. And this is not the most ideal as you may need to pour up a new model afterwards. But when using the impression scan bodies, a major upside is that you have all the space in the world and will never come across the situation again. All right, so as mentioned before, you will notice that there is no screw access hole on the top of the scan body. And this is mainly because you are going to be utilizing the included screw from your impression coping to attach to the scan body. Now with this, you will notice a larger surface area from the occlusal surface of the scan body itself. And in turn, this will actually help provide a better alignment and an overall higher accurate final product. So we also do have plans in place to actually incorporate future scan targets on these scan bodies. And basically with these scan targets, it'll help provide an auto alignment feature along with the automatic library detection. So I know a lot of laboratories out there, I mean, they've been processing cases and there comes to a point where they accidentally select the wrong implant system for the case. And what I see now is that automation is pretty much key for a lot of these processes. So, again, keep in mind and stay tuned. We are most likely going to be incorporating some scan targets on these scan bodies that will provide automatic solutions for your library detection and auto alignment features. All right. So although you will see quite a bit of benefits already for producing your modelless single implant restorations directly from your impressions, a huge major benefit that will be outlined during Joe's presentation is the use of these scan bodies for your full arch implant prosthetics. So this picture that I'm showing right now is a case that Mr. Joe Santos, he had completed in the past utilizing the impression scan bodies. And this is where he became a believer of the product. This will also be the exact case that he will be demonstrating today. Now, do keep in mind that when scanning directly from the impression, it is helping to avoid the issues of running into some possible inaccuracies that may come about when pouring up your stone model. And these can be instances such as your analog possibly tilting during your pouring process. So here at Imagine, we actually pride ourselves in milling highly accurate bars and full arch prosthetics. And what they all start off with is a highly accurate scan. So in order to promote this, generally we utilize a touch probe scanner called the Renishaw DS10. And this scanner generally scans at about under 1 micron accuracy on the Z-axis. So throughout this process, we generally scan all the model details utilizing an optical scanner for speed. And then we utilize the Renishaw DS10 for supplemental scans when it comes to the implant position itself. Now, with the use of the impression scan bodies, we were actually able to find that throughout our testing and production, we were able to create a high accurate environment where the use of the supplemental touch probe scanner wasn't really necessary anymore.
So this to me is one of the more compelling reasons to use these things. I mean, even under the best circumstances, you're going to get some shifting. No model material is perfect and no lab technician is perfect. yet somehow we're expecting them to get nearly perfect results. And I mean, you know, some of the deviations you mentioned in the previous slide there, Josh, actually, if you don't mind going back to it.
Yeah.
I mean, a 22 micron deviation, you know, that's, you know, about a third of a human hair. 78 micron, that's about, you know, the width of a human hair. Those seem small, but as many of us know, in order to get these full arch cases to seat passively, pass the Sheffield test, you can't tolerate 78 microns of inaccuracy, you know? So these are a huge benefit in my mind, not only for quality, right? Increasing the likelihood that you're gonna get a great passive fit first try, but also efficiency, right? Because right there, you were talking about a process, you know, if we just kind of compare apples to apples, you know, you get the impression, you know, using the old way, you get the impression, you need to take your time to pour the stone model, you know, make sure you use, you know, the right materials in the right areas and you bake it in the right way to make sure you get a good accurate model. And then when you've finally gone ahead and done that, then you can pop it into your lab scanner, you know, use the traditional analogs and scan bodies to get your locations, your heights, your angulations. And then maybe you need to go on to yet another scanning process to get even finer, more accurate information on those, you know, specific implant sites. So rather than doing all that with the impression scan bodies, you just take the impression, you apply the scan bodies, and you scan it, and you move on to your next step. I mean, it's such a tremendous benefit in terms of efficiency, and the accuracy is just the icing on the cake. So to me, efficiency and accuracy are two of the most compelling reasons to implement the impression scan bodies. Another great question here from Dr. Graves, does Imagine plan working with Medit for auto alignment for scan bodies? Now, I know we work very closely with Degree of Freedom. Is any of what we're developing here, Josh, does it translate to Medit?
It will not. So talking about the scan targets, this is a future development that we'll have in place. And as long as the scanner, as long as it's able to actually scan these scan targets and reference these scan targets as well, basically, we're going to be moving this information over to ExoCAD, where actually that auto alignment feature will come into play, right? So, I mean, to answer your question, there's a good possibility in the future that we'll work with Medit to have an offering for this method.
So, but right now, to be clear, this workflow that we're describing is available using, of course, the impression scan bodies from Imagine, but also the Degree of Freedom scanners that we also sell, correct?
Yep, exactly.
Okay, perfect.
All right. So moving over to the next slide. So, I mean, basically with this, you will now be able to design your bar and mill out of, you know, either metal or PMMA for a try-in and to verify the implant positions are actually correct. This is a very important part of the process, making sure that what you have on your stone models generally is accurate according to what's in the patient's mouth. So basically with this method here, pretty much you're going to be scanning directly from the impression. You do have the opportunity of actually milling out the prosthetic, either out of metal or PMMA right away. Get it over back to your doctor for a try-in and to verify that all the information is indeed correct. And this is even before printing or pouring out your model. All right. So I want to talk about a little bit about current availability. So as far as our availability goes, we currently have the scan bodies available for about 4 different implant systems currently. We will be adding more to this list, but what we currently have available are these impression scan bodies for biomed. We have it available for a Noble Replace, Noble Multi-Unit, and a Zimmer TSV. We'll definitely have more coming here shortly, but if you look at this list here, you'll be able to see that we have implant components for about 24 different implant systems. And for these components, what we have in stock are 3D analogs for printing, titanium bases, engaging and non-engaging, titanium bases for angle screw channels, screws, and drivers as well too. So pretty much we're going to be your all-in-one shop for these implant components. And with the use of these impression scan bodies, you'll have all of these components readily available too. So at this point here, I actually prepared a video that I actually go over the scanning process. So let me go ahead and start by playing this video here. Now, do keep in mind that the scanning process outlined here is based off the use of a DOF scanner. And this is incorporating a special workflow that we help develop for the specific function of scanning your impression scan bodies. So if you have a DOF scanner already, we will have a software function finalized here shortly for this process. Now, starting off, we're going to go ahead and start off with a lower impression scan, and this is without the incorporation of the scan body itself. This is where you're going to be capturing a lot of your details when it comes to the contacts, your tissue, and even the interface from the impression coping. Now, at this next step here, we're preparing the impression with the scan body. All right, and once all details are complete, we're going to move on to the next scan, which is for your upper impression. All right, and finally, we're going to be scanning the byte registration.
And Josh, just to clarify, this is all being done on the Degree of Freedom HD scanner, right?
Yes, correct.
Okay. Yeah, the UHD is another popular model. Has a much higher resolution. As a result, it scans a little slower, but it's still a great. If you're looking for an ultra high resolution scanner, it's definitely one of the best out there. Josh, is that your 3D printed holder that I see there?
Yeah, it was a little bit of ingenuity in place, but basically I saw that when you're scanning the byte registration, there's actually no holder for it available from Degree of Freedom. So I actually designed and printed out my own.
There you go.
In case any of you guys have a DOF scanner and you want to utilize this, I can send you the STL files. So just let me know.
Yeah, and it's an open STL file, so you can print it on a home hobbyist printer. You can print it on your Formlabs or on your NextDent. Oh, it looks like Ben over at Muller Dental Arts wants that as well. So
all right, beautiful.
If you can, Josh, go ahead and post that in the chat feed if you have a link to it or anything like that. Otherwise, we can be sure to post a link to it on the YouTube video when we post it.
Yeah, sounds good. Yeah, I'm gonna go ahead and post it up in the chat feed here in a second.
Beautiful.
All right, so basically at this point, we're finalizing the process with the alignment of all the scans.
We're getting many requests for that holder there, Josh. Be sure to.
Okay, beautiful.
Be sure to give him that.
All right, sounds good. So basically at this point, we're trimming off excess information that we're not going to need for our design process. And pretty much at this point, we're doing the post-processing, which is cleaning up the information. And there we are with our final product for our scans. Now, do keep in mind that the byte registration was actually not the most accurate. So you'll actually notice an open byte on here, but I'm hoping that this video kind of outlined the exact process of what you'd be running into. Now, if you do have a need for this workflow right away, I do have a beta software in place. So feel free to reach out and we'll try to get the software in your system. So now, without further ado, I think we can switch gears over to Joe Santos, who's going to be going over a design process for an all-on-5 restoration. So I'm going to go ahead and stop sharing my screen now.
Beautiful. Joe, are you there? Can you turn on your audio and your video?
There you go.
There he is.
All right.
There he is.
Hey, what's going on? Okay.
So I guess
Alright,
just to
go
kind of
ahead.
kick things off, I mean, how, I know you've been running your lab, Virtual Access 109, for, quite a while now. How long have you been using the impression scan bodies?
Just I started January. January. So far I've been just working with one doctor, and we probably did, I would say, 8 to 10 cases now.
Wow.
And what we do is we deliver it the same day. Well, he scans, he places the implants, he takes an impression, and then he sends the scans to me. And that day I'm gonna design a PMA with pink and everything and mail it out.
Yep.
I mail it the same day, and then the next day I'm gonna ship it out to him. I'm overnight it.
Okay.
Once I overnight it, then the patient comes in 2 days later, he has his prosthesis. But now he's what we're doing right now, this is like, January. So right now what we do is we take a scan, I design them, I send them to him right away, and then he prints them.
Gotcha.
That's what we've been doing. And so far we pretty good. I mean,
yeah. And it's funny because, that type of highly efficient digital workflow is like, that's like the holy grail for some labs, but it's great to hear that you're achieving it. So, I mean, basically he places it, he does the scan, sends you those scan files, you do up the design, send it back to him. He prints it there in his clinic.
Yep.
Do the provisional, he can do the try-in, and then whatever feedback you need, you design the final, produce it, and boom, no model needed.
No model.
Beautiful thing, man. Okay, I won't bore you anymore. Why don't you dig into ExoCAD here and show these people what they're looking to see?
All right. Okay. All right, so let me see here. Let me share my screen here. Stop the video here real quick. Sharing. Sorry about that, guys. My son is here, so.
It's all right. I think most of us have our kids at home these days.
All right, so, oops, what happened here? Let's see. Shit. Where's is this the one? Oh, this one. Okay, can you guys see my desktop?
Yeah, we can see your Zoom screen there.
Okay, cool. All right, so what I'm gonna show you guys is I'll show you this case that I just recently did.
Joe, I think you might want to double check what screen you're sharing there, because we're still looking at your web browser, not.
I gotcha. Let me just see here. Okay, share screen. All right, can you see now?
Yep.
What the heck?
We did for a moment there.
No, huh? All right. Which?
There we go. Now we can see your desktop. Looking good.
I can see my desktop? Okay, good. All right, here we go. All right, so this case is it's a lower all-on-5 case. Patient comes in 2 weeks before her surgery. The doctor took a upper and lower impression bite. He sent that to me, which I'm going to show you now. All right, so come on. Yeah. Okay. Let me just get this down here. Get this thing out. Get that out. And then, okay. These are the scans that he sent me prior to surgery. Upper, lower, and bite. Okay. So what I did is I put it on my computer, and then I took out the actual teeth that are going to get replaced. So what I did here is this is how I did it. I right-click this and then just basically just edit the mesh. Okay, once you edit the mesh, from here, and kind of like just, yeah. Everybody here probably knows how to do this. Okay, so I'm not even gonna go very detailed here. So, and then once I deleted the teeth, right, I made my model now. So which is this? I got my jaw. Okay, so I get rid of this. Oh, by the way, this doctor, I mean, I love him to death. He take that bone out, like literally, like there's no bone. So he really grind that bone out. So I'm gonna show you guys here. So now, it digitally wise, I have my kind of like my jaw now, my lower jaw. Then I got my antagonist, and this is the pre-op, or which is his actual teeth. Okay. And then from here, what I did is I started designing it as a denture. Once I decide denture, okay, I'm just gonna show you the denture side, which is this one here. Oh, actually, you know what? I didn't save it. This is the actual case that is finished, okay, the wax up. Okay, but let me show you the denture that I have that I made for this guy. And add a little mesh, generic, no. Okay, pre-denture. Okay. So this is the denture that I made for him. I gave this to him to get it printed. So he printed his own denture, and then he used this denture for surgery. Okay. So now this is what he asked me. So that's the design, that's the wax up, and this is the denture. Okay. Right there. So what I did next on this is when the surgery came, what he did, he used the denture, he took an impression of the scan body, and then he put impression post. It's like a regular, like kind of like you're making a verification jig. Once you make a kind of like a verification jig, you look them all together, and then he took out open tray impression. Once he took out open tray impression, on the underside, he screwed on the impression scan body. And let me show you this one here. So this is the impression scan body that he gave me after the surgery. So which is the denture impression. Okay, so this is the impression scan body with the scan body. So the denture that he uses, that's the denture that I designed for that surgery, and he uses to capture the tissue and then the implant position. And the main important thing here too is before he take it out of the mouth, I told him to take a picture of the patient with and without retractor. Make sure everything correct, midline's correct. Want to make sure everything is good, nothing's scanted. And once he said, "Yeah, Joe, this is perfect. Let's just go ahead and proceed with this." So I told him then, so if we don't have to adjust this, or we don't have to adjust the bite is perfect, right? So we don't have to adjust nothing. You don't have to take the scan of the upper, because the upper stays no matter what. So, you know, we're not doing anything to the upper. So from there, what I did is he sent me the scan, and then I put in my my exocad. Then from here, what I'm gonna do is I'm going to superimpose this denture with impression scan body to the denture that I designed. So everything is fully workflow. So you don't have to, you only have to design, or maybe, you know, if the bite's off, maybe you have to adjust the bite or something like that, but you don't have to redesign the case, okay? Because you're working on the original design from the beginning. So what I do next is I'm going to superimpose this too. So tools, align mesh, okay? If you have any questions, please feel free to ask, please. You know, we're doing this right here. Best fit match. Well, okay. See, now that's pretty close. You want to see a lot of blue. Blue is more like the when you look at this side here, where my mouse here, blue is more like very accurate right there. Okay, that's the closest we can go. Because plus the printer that he uses is not that great. Okay, okay. So it's up to the it's all up to the printer and how accurate the printer is. So we can work with this. Then what I'm gonna do next is I'm going to hit clear. Oh, that question. Oh, okay. So now I have the opposing, and then I get rid of the pre-denture. So now we have this. So we captured the bite, we captured the impression scan body, the new tissue impression, all in one. Okay, so that's what we do here. So when I hit, okay, we're gonna hit X this out. So how do I make this into a model? Okay, so what I'm gonna do here is I'm gonna get rid of this, right? Let me just save this here, because always sometimes a little messed up. Okay, so what I'm gonna do is I'm gonna modify this actual model here. So right click the actual denture, edit mesh. Now get rid of the denture that we designed. Okay, right here, right there. And just gonna cut this. Here. Almost done here. All right. So now we have the actual tissue impression. At the same time, we have the scan body impression. So what he did, he has a, I think Medit. Yeah, I think he has Medit. Yeah, some Medit, okay? And he actually scanned this model. I didn't. He scanned this model to me out of the, after he took the impression. And earlier we were discussing about scanning intraorally with the scan body. It's hard, especially in the lower, because tissue moves. And the second part is it's a little too much blood, you know. And some scanner is really hard to scan those. And trust me, been just scratching your head. I'm like, is this even accurate enough? You know, and all that. And what we did is like, why don't you just take an impression, look those implants together, take impression, and then scan it outside the mouth. And this is what he did. We scanned it outside the mouth, and then he sent this to me. And then he had to make sure that everything was seated, and he said, yep, everything's good. And here we are. No, less stress for him. He doesn't have to rescan. He doesn't have to scan all over the blood and all that stuff. So this is much more faster and more, I would say, accurate. Because sometimes blood, man, that can add to the scan bodies, and it's really hard to capture those. So, okay, so moving on. Here we go. So here's my model now. Okay, let me just hit cancel here. Okay, because I already made one for you guys here. So I'm gonna add this tools. All right. I guess I didn't. Oh, yeah, I did markers. Okay. Okay, so what we can do now, these are the same models. Okay, so tools again. You're gonna love this option here, align mesh. This is your best friend. You can add anything you want, keep aligning them if you want. You know, it's a good tool to have. Okay, now that's 100% perfect right there. Okay, clear.
That's a lot of blue.
That's a lot of blue, exactly. Okay, so what I'm gonna do now is now we have our jaw, we have our pre-op denture, and we have our antagonist. This time now we can go ahead and start designing, or not designing, I say importing the design to this case. Because I already designed this case already, okay, which is this one here. It's right there. So now we get rid of this here. So there's our bridge with where the gonna be implants at. Okay. So what we're gonna do next is gonna start saving scenes. Okay, we're good here. So just want to make sure that everything is clear before I move on. Any questions?
I don't see anything coming through, so I think we're good to move on here, Joe.
Oh, okay, awesome. All right, cool. So the next one here is gonna start saving stuff, right? So we're gonna get rid of everything here. Okay. So we're gonna put on. We don't have to put on the antagonist to make it finalized, because we don't need to, because everything is perfect from the start, right? Which is a good thing. So what I'm gonna do here, I'm gonna bring in the markers, right? We're gonna name this as our new lower jaw. Save, yes. Default, okay? Now we're gonna get rid of that. Now I'm gonna bring in the wax up, which is this one here. Anatomic wax up. The design that we did prior to this case, right? Because this is the design, that's the printed denture that I gave the doctor. As you can see, I just went back and just cleaned it up. Basically, I just cut off all those ridge out here, right? And so that's our wax up. So I'm gonna do it here. I'm gonna right click, save scene, STL. And I'm gonna name it as our wax up. Hit this default. Always default. Okay. Now when we're done with this, let me see here. Bring that command. And then now we can proceed on finalizing this case. That's all you need for this case here. That's the wax up, the tissue impression, and then the scan markers. Okay. So there's 5. 1, 2, 3, 4, 5. So we're gonna minimize this. We're gonna open a new exocad. All right. Naming this basically is kind of like it doesn't really matter where you're gonna put the implants, because it's a wax up. You know, it's a final bridge. If it is a single bridge, I mean single implant or individual implant crown, yes, numbers matters. Okay. So on this one here, always check. So we have first molar to first molar occlusion. So and then there's 5, right? So 1, 2, 3, 4, 5. So I just basically kind of like where I'm gonna put my implants. Yeah. I can come here. So I'm gonna do anatomic wax up. It doesn't matter, whatever. PMA is fine. Screw retain. Pre-op no. Gingiva no. Even though we're gingiva, but we're gonna use the gingiva now. Scan wax up, yes. Okay. So I go choose 19, 17, 27, 22, and 25. And the rest will be Quantic wax up. Okay. So and hit save. One model only.
Real quick question here from the audience.
Yeah.
Christina's wondering how does the dentist put the impression scan body in the denture?
Oh, good point. Yes. So Christina, so he took an impression, a verified impression, right, in the impression mouth. So kind of like those non-engaging impression coping. Okay. So he put that. He looked them out in the mouth, and then whatever the dentist is doing the verification jig. Basically, it's a verification jig, but with impression. Okay. And he uses a light body and a heavy body. Once you take that out, that's why Josh said use an open tray impression so you can see it clearly. So yeah, I'm screwing them out, and then once you unscrew it, now he can put the impression scan body into the impression coping, and he scans. That's how. Okay, and he sent that to me. Okay, so we got that right, and I hit save, and get design. Remember, we're not going to design anymore because we already designed a wax up from the beginning, which cut the time in literally. That's why I can send this case to the doctor in literally like 20 minutes. I like 8 drops. You can print this out. You're done. You know. All right. So we're going to go desktop here. We're going to find those files here. I think it was here. Yes. So the lower jaw and then the wax up, right? So it says here, load lower jaw. Load the lower jaw. And the same thing, load the marker. So it's the same thing. Then the wax up. Okay. Okay, so before we do this, don't even worry about this one yet. Not yet. We're not even going to do this one yet. Okay? Like this. Now, we don't want to invert this, okay? We want to invert the model, which is this one here. This is the one that we want to invert. Because right now, this is it's upside down, okay? On Exocad, you could invert it without any third party doing it, okay? So what we can do is how we're gonna do this. So we're gonna right click the background, right click the jaw, edit mesh. Right click the background again. It says here show triangle orientation. And then right click the background again, invert. So now we have a nice positive model. And I hit OK. Okay. Now from here, we can just edit mesh again. Okay, I'm just going to clean all this up. And that's how I invert models or impressions. And then I'm just going to close holes here. Okay, then from here, what I'm going to do is I'm just going to smooth out this area, free from scan data. All right, let me go back here. Right click the jaw. Freeform scan data. I'm just gonna split this area out just to smooth them out. Because that's the impression here. Well, you don't want to touch the actual gum, so that's the actual replica of the patient's tissue after the surgery. Okay. Okay. All right. So now we have this. Oops. See that right there.
And just a quick comment for anybody who might have joined us since the beginning here. If you have any questions for Joe throughout the course of this presentation, definitely go ahead and add them on the Q&A box or on the chat line, and we'll be sure to get those answered for you. So submit any questions you have on either one of those methods, and we'll make sure to get them answered.
Okay. So now we have our model, our jaw. I have a wax up in our impression scan body. The impression scan body, we don't want to invert, because if we inverted the scan body, the actual tissue, the actual scan body will be upside down. It will be coming out of here. So that's why you have to invert just the model. Okay. So get rid of this here. You're gonna have scan body. Okay. Now we just go ahead and go back. Now we can go to wizard. We can go to this one right here. So that's the scan body right there, right? Scan body. That's fine right there. So hit yes. Hit next. Okay, 36 for you guys. Excuse me. So it's kind of like looking at this right here. So 1, 2, 3, 4. So it's kind of like the I forgot the name of it. It's not universal. It's universal. Anyway, go ahead. Get out of here. All right. So library. Going to go in this here. TSV. Did I not put it?
It's got to be in there somewhere.
Yeah. No, I did. Oh, hold on. It's all messed up here. Yes. All right. Here we go. Okay. TSV. Oop, right there. Okay, tapered screw vent 3.5 IMP impression. Okay. Okay, we're gonna go L link, the tallest they have. And I'm gonna go bridge. Use anyway. Now from here, I'm gonna choose here. See how the orientation of the scan body is right here? That's why we don't want to invert it. If we invert it, it's gonna be this way. You know what I mean? So now let's go right here. Never invert the scan body, only invert the actual jaw. I mean the other model. That's why I have 2 of them. Okay, so here. Okay, that's blue. Blue is good. Use here. Okay. Next. Okay, and then when you look, let me just go back here. 1 second. Okay, here's our tie bases. All right. Okay. Oops. Oh, what happened? What happened there? Hold on, I'm gonna go back. Just go back. Did I just not do fine? Oh, see that, guys?
You missed one.
No, I missed one right there, huh? So that's fine. So we're gonna be an all-in-4, okay? All right, so just go back here. So we're just gonna add this one here. Okay. So now from here, I only touch this design emergence profile only if kind of like those if really subject. And on this one, I'm gonna design this as a high water denture. I don't want to put pressure on that which one? The tissue. Okay, let's hit next. 2, 3, 4. Okay. Now bring in your jaw. Now I'm gonna do this. I'm gonna kind of like bring this straight here, just like this, a little bit. Okay. The reason I brought that up is because if you don't bring that up, it's gonna be very thin on that area where the scan body is. Okay. I mean the scan body, the tie base. Okay. So I'm gonna hit next. Now it's calculating the wax up for you.
And Joe, something that people might be wondering here, I mean, of course, you're using L-links from,
Mm-hmm.
which of course is our own line of implant components, and we would love everybody to use those. But let's pretend you wanted to start with an impression scan body from NIST, but then use another implant component from another company. Do you have the versatility, the flexibility to be able to do that with this workflow?
Yes, you can. Absolutely.
Yeah, good. Well, I mean, options are a good thing to have. Like I said, we would love everybody to use our missed implant components, but we know sometimes for various reasons, other components are necessary. So that flexibility is a really good thing.
Absolutely. No, that's true, man. That's true. Always have a backup.
Yeah.
Always have. Okay. So what I'm gonna do is I'm just gonna modify this bridge real quick. I'm just gonna add that in there. Okay. Next thing I'm going to do is I'm going to adapt, bring it to 0.05. Off the tissue. Okay, so you're going to see that right there. I'm going to get rid of this and get rid of my model here. And then going to freeform this real quick.
Quick question here again from Christina. She's
Yeah.
wondering if this means we can use other components for multi-unit abutments too. I think the answer to that's yes, right, Joe?
Correct. Yes. Imagine has the multi-unit abutment scan body, which is perfect. I mean, you can use it from Tri, Straumann, Nobel. You know what I mean? So yes. But this doctor that I work with, he uses he only uses this implant, the ankylose. Oh my goodness, I hate those freaking. So he uses that, and which is compatible with the TSV 3.5. That's why it worked well. He doesn't. Oh, shoot, someone's here. So he doesn't do this. I mean, doesn't use the multi-unit abutment. Anyway, so let me just freeform this real quick. Just smooth it out. This is what I'm doing. I'm smooth out the area here. And try to design it kind of like a convex. Okay. I'm bringing that. So now you see more. Again, you're gonna adapt it. Okay, bring it down. Yeah. I'm going to smooth that in now. Like this. Now. Okay. And that's how I designed this bridge. I'm gonna hit expert mode here. Okay. And yeah, that's finalize the bridge. This one's ready to get printed or mill. I mean, this is how my workflow is, and hopefully that you guys understood it. So, yep.
Beautiful. So at this point, you'd send this resulting file off to the doctor. He would go ahead and print it for the try-in. Or
Actually, this one here, patient will wear this for 3 months.
This will be your provisional.
Correct. Instead of conversion denture.
Gotcha.
Because the patient, what we do is patient leaves after when they place the implant, all the impression was taken. Patient go home, come back the next day, and then we place this.
Beautiful.
And this is how my work plan. We don't deliver the same day, unless, because if I'm in New York, I mean, if I have a local doctor, yes, we do it the same day. But technically for him, he said this fine. The patient's drugged up anyway, so he just want to go home and just rest. So.
Of course.
Yeah.
So this is a workflow that is readily available to anybody who has, exocad and a DOF scanner, does this type of implant work. Available for the implant systems that Josh mentioned earlier, just off the top of my head, that was tapered screw vent. I believe we did 3i Certain, Nobel.
Nobel, yep.
and there was a fourth one in there. If you can remind me, Josh, if you're still on.
Yeah,
But,
I believe I think you're missing the Zimmer TSP.
Oh yeah, that's right. The one we're using now.
Yeah. So, and that's the beauty of it is if you guys, anybody who's listening or watching, if you already have a DOF scanner, you're already using ExoCAD, this workflow is available to you. The impression scan bodies are not expensive. And
No,
we
no,
are in stock right now, so this is a tremendous efficiency that is not too hard to implement and not costly at all to obtain. So it's actually a pretty tremendous benefit.
Yeah, actually, I'd like to chime in on just to clarify one piece of detail. So basically, this process for the scanning, it's not tied in only for the DOF products. It's actually available for any open scanner. The only difference is that when utilizing a DOF, we're actually creating our own scanning workflow. And basically, what Joe outlined here today was pretty much a workflow in the case that a doctor or laboratory is utilizing any other type of scanner. So I think, Joe, you mentioned that the doctor, the scanner that he had in place was currently a Medit scanner.
Yeah, intraoral scan. Yes.
Yep, exactly. Okay, great. So, basically, again, you can use any open scanner in the market. What Joe outlined today was basically the process in which he was inverting scans according to scans coming from any other type of scanner.
Oh yeah.
Keep in mind again that from the DOF scanning workflow that I was portraying a little bit earlier, this kind of outlines a process where basically you're able to scan all the information you need and all the inversions and whatnot orientation for the scan data will automatically take place in the scanning software from DOF.
Gotcha. I think that's a pretty important distinction to make. So the scanning software that we've kind of worked with DOF on will give you kind of the most optimized, fewest number of clicks workflow. But I think Dr. Graves was asking earlier, let's say I have a Medit scanner, can I still do this? The answer is yes, right? You might require a few more clicks. It might not be as kind of streamlined as we've worked with DOF to achieve, but you can still have all the benefits of a model-free workflow, even with, a Medit desktop or a Medit intraoral scanner, or, like you said, Josh, any other open 3D scanner.
Yep, exactly. Mm-hmm.
And one thing too, let me just add just to this. For Dr. Nathan Graves, Doc, because I know you've been doing some impression-less small scanning. I'm not gonna name nobody, but so this one, Doc, you can do it the actual same day. I mean, you have a mill. I mean, you can design, print or mill, whatever you gotta do, without the hassle of blood. That's the only thing. That's what I love about this. Is the blood. When you scan blood, man, it's hard to scan.
Right.
I mean, I'm not a doctor, but I tried to do it. I was there. I'm like, oh my goodness, man. And we use alcohol. I mean, not alcohol. We use Listerine. We have them goggle with Listerine, and it helps a lot. It helps a little bit, but not much.
Yeah.
Not much. So.
Beautiful. So if anybody has any final questions